Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good morning. So today we are going to discuss about multiplexing. So in this chapter, I'm going to explain what multiplexing is and what are the techniques for multiplexing. So what is multiplexing? Multiplexing is a set of techniques that allow simultaneous transmission of multiple signals across one link. So as I mentioned before, in the signal, in the chapter of signal, we are not sending a single signal. In real life, in real implementation, we are sending multiple signal. So how to send a multiple signal across one link? Okay, so multiplexing technique need to be implemented. So the single signal from a single source need to be combined with other signal before it can be transmitted. So what are the technique to be used, and what is the technique to be used to combine those signals? We use the technique of multiplexing. Okay, so as we can see, as you can see in the figure, so we have 4 sources. Okay, so from these 4 sources, it generates 4 single signal. Then each and those signal need to be combined. Okay, so how to combine? Use multiplexer at the sender side, so that multiple signal can be combined so that it can be transmitted across one link. So at the other side, we have demultiplexer to separate the signal into its original signal, so that the receiver, the specific receiver, can receive the signal that being transmitted by different sender. Categories of multiplexing. Multiplexing can be divided into two, because it depends on the type of signal. So signal, we have two type of signal, analog and digital. So for different type of signal, we use different technique. Okay, right. Okay, so for analog signal, we have two technique. The first is FDM, frequency. The second one is WDM, the wavelength. Okay, frequency is for electromagnetic signal, wavelength is for optical signal. And then for the type of digital signal, we have TDM, time division multiplexing. Okay, first let's look at the analog signal. So analog signal uses two type of technique. One is frequency division multiplexing, and the other one is wavelength division multiplexing. So as I mentioned before, FDM is used for electromagnetic signal. So what is FDM? FDM is an analog multiplexing technique that combine analog signal. So FDM is used for analog signal. So it can be applied. FDM can be applied when the bandwidth of the link. Okay, so you can see the link. So this is the link, and this is the link. Okay, when the bandwidth of the link is greater than the combined bandwidth of the signal, this is the combined bandwidth. This is the combined bandwidth of the signal to be transmitted. So if the bandwidth of the link is greater than the bandwidth of the signal to be transmitted, then FDM can be applied. Okay, these are the process in the process of FDM technique. So we have three process, and the first one, each source generate a signal of a similar frequency range. Okay, so we have how many sources? 1, 2, 3. Three sources generate three different signal with similar frequency. Okay, now at the second process, in the multiplexer, so in the yellow box, this signal modulate different frequency carrier. So it means that the original signal will be combined with the carrier signal, okay, to produce modulated signal, and this we call as modulated signal. Okay, so we have three modulated signal, and these three modulated signal will be combined in step 3. The resulting modulated signal are then combined into single composite signal. So we have a single composite signal. Okay, so that's done at the multiplexer. So this is at the other side, at the receiver side. So this we call as demultiplexing or demultiplexer. So we have two steps over here. Step 1, demultiplexer uses a series of filters. So we have a filter over here to decompose the multiplex signal. So we have, by implementing the filter to the composite signal received, so it will produce the modulated signal. This modulated signal will be sent to the second process, the second step. Individual signals are sent to the demodulator. So when this modulated signal combined with the carrier frequency, it will produce the original signal. So that's the process of demultiplexing. Okay, so example 1, assume that a voice channel occupies a bandwidth of 4 kHz. Okay, we need to combine 3 voice channels, okay, into a link with a bandwidth of 12, 20 and 32. Okay, I mean 12 from 20 to 32 means each 12 kilohertz. So total is 30, and we have okay, a bandwidth 3 voice, not each. So the combination of the voice channel is 12 kilohertz. So show the configuration using the frequency domain, okay, without the use of guide band. So what is the answer? Okay, so we have each voice channel has 4 kilohertz bandwidth. Okay, when it combined, equal to 12. Okay, so between 20 to 32. So this is the combination of the signal. This we call as a composite signal. So these three voice channel has been combined by using multiplexer. This we call as multiplexer. So when it is combined, and when those signals are combined, it produces a composite signal. Okay, so this is at the demultiplexer. Use implement filter, apply filter to generate the original signal, and then can be received by the receiver. Okay, I think you can try by your own for this example. Okay, just to be remembered, just to be careful here, we have a guide band, so you need to consider a guide band of 10 kilohertz. It's over here. Yeah? It's over here, the guide band. So five channel require 4 guide band. 1, 2, 3, 4 guide band. Okay, so you need to consider 4 guide band. 4 times 10 equal to 50. Each channel has 100 bandwidth, so times 5, so the total is 540. Analog hierarchy, this is how we simplify the group of multiplex signal. So we can start with a group. So a group of voice channel will consist of 12 voice channel. So each voice channel has 4 kilohertz. So 4 times 12, okay, equal to 48 kilohertz. So each group consists of 12 voice channel and 48 kilohertz. Okay, so this we call as a hierarchy. So because it's going larger when it goes upper. So the next one we have supergroup. Supergroup consists of 5 group. So 5 group equal to 60 voice channel and 240 kilohertz. Okay, so you just multiply to get 60. So 5 times 12 equal to 60. Okay, the next one is master group. Master group consists of 10 supergroup. Okay, so 10 supergroup equal to 600 voice channel. So to get this 600, 10 times 5 times 12. 10 times 5 times 12 equal to 600 voice channel. Okay, from master group, okay, the combination of 6 master group become jumbo group. So jumbo group consists of 6 master group. 6 master group equal to 3600 voice channel. How to get this value? 6 times 10 times 5 times 12. Okay, equal to 3600. Okay, done with FDM. Now we are going to discuss about wavelength. Okay, wavelength division multiplexing technique, the second technique for analog signal. Okay, so WDM, okay, is analog multiplexing technique. Okay, to combine optical signal. Okay, this is in fiber optic cable. Okay, usually used in fiber optic cable. Okay, so this is light, and this is the signal is in the form of light. Okay, so light can be measured in wavelength. So it use multiplexer over here, normally a prism. Okay, so this is the multiple signal. Okay, so this is the multiplexer. Okay, it's the same as the multiplexer, use prism, and then this is the original signal to be received by the receiver. Okay, this is what I have mentioned just now: multiplexer, demultiplexer, and prism. Use prism over here, and these are the signal and light signal, light. So it can be combined using prism and separated back using a prism as well. Done with WDM. Now we are going to discuss about time division multiplexing and TDM. So TDM is used for digital signal to combine data. Okay, it said that in TDM the data rate of the link is n times faster. Okay, the unit duration is n times shorter. Okay, so it's over here. If you look at the figure, so we have 4 sources. Okay, we have 4 digital signal. Combine use multiplexer, and this is the multiplex signal. This is the multiplex signal, the combined signal. Okay, so same, use demultiplexer to separate it back so that it can be transmit or received by the receiver. Okay, this is the TDM process. Okay, so in TDM we have frame 1, frame 2, frame 3. Okay, so the transmitted data will be combined into a frame. Okay, so look at the first 3t. This we call as 3t time. 3t time. So first and the first period. So at the first period, the data or the binary data, because the digital signal is in the form of binary. So the first bit will be taken to form the first frame. So that's what we have: A1, a blank space, and C1. Okay, so the first 3T will be combined to form the first frame, to form frame 1. Okay, so frame 1 will be divided, each frame will be divided into the number of sources. So if we have 3 sources, so each frame will be divided into 3. Okay, so that this we call as a time slot. So each frame has 3 time slot. Okay, so each time slot will contain bit from every sources. Okay, so now let's look at the second 3T. Why we call it as 3T? This 3T second. So the second 3T second, the second 3T second, in second, the unit, it will form the second frame. So the second frame contain A2, B2, and blank space. So the next one, at the third 3T, okay, it will be combined to form frame 3. So frame 3 will consist A3, B3, and C3. Okay, that's the way how the digital data will be combined. So it will be combined in each frame. So the number of frame is depending on the number of bit that bit transmit. Okay, now let's look at this example. Okay, so we have 1 kilobit per second connection. So we have 4 sources or 4 signal to be combined or to be multiplexed. A unit is a bit. It means that in each frame it will contain 1 bit. In each time slot. In each time slot it will contain 1 bit. So so in each time slot over here, in each time slot it will contain 1 bit. Okay, so find the duration of 1 bit before multiplexing. Okay, now 1 bit before multiplexing means that at the and before multiplex, and before means so we know that the data rate is 1 kbps. 1 kbps. In a minute. 1 kbps is over here. And 1 kbps. Okay. So the duration of 1 bit is 1 over 1000. Okay. So the answer is over here. So the duration is 1 over 1000, or equal to 0.0 second or 1 millisecond. The rate of the link. So we have the rate of the transmission link, as we have 4 signal to be multiplexed, so it is equal to 4 kilobit per second. The duration of each time slot. So what is the duration of each time slot? Is over here. So the answer is the duration of a bit, which is equal to the duration of a bit after multiplex. So 1 over 4, 1 millisecond over 4, because we have 4 time slot. So what is the duration of a frame? Equal to the duration of a bit. The duration of a bit. Okay, interleaving. So we have here interleaving. Okay, it used for synchronization. Okay, so just to make it the transmission synchronized. Okay, so the next example, 4 channel are multiplied using TDM. Okay, if each channel send 10 or 100 byte per second, 1 byte equal to how many bit? Equal to 8 bit. Okay, so 100 byte equal to 100 times 8 bit. Okay, so 800 bit per second. And we multiplex 1 byte per channel. Okay, so means that each time slot we have 4 channels, so we have 4 time slot. So each time slot contain 1 byte. Or equal to 8 bit. So each time slot over here equal to 8 bit. 8 bit. Show the frame traveling on the link, the size of the frame in byte or bit. So the size of frame in byte, so 4 byte. The size of frame in bit, 8 times 4, 32 bit. The frame rate and the duration of a frame and the bit rate. Okay, look at the answer over here. So this is the explanation. Frame, the size is 4 byte or equal to 32 bit. Okay, 100 frame per second. Okay, or and because we have 332. Okay, let's look at the answer over here. The size of frame 4 byte, 32 bit. The frame rate. The frame rate is 100 frame per second. Frame duration divided by 100 frame. Okay, bit rate equal to frame rate multiplied by 32. Why? Because each frame contains 32 bit. Okay, so example 6, I think you can this is a bit different because each time slot of 2 bit means that we have 4 time slot. Each time slot contains 2 bit. So you need to be careful about this. Okay, we have 400 kilobit per second. Show the output with 4 ununiform input. Okay, so this is the answer. Okay, so 2 bit for each time slot. Okay, so the question, size of the frame 8 bit, and because 4 times 2, frame rate frame rate equal to 50 kbps. Okay, why 50k? Hang on a minute. 50k because of actually what is the it is 100 kilobit per second and the bit rate 100 kbps. So I think it is easy to calculate like this. 100k, so each time slot will consist of 2 bit. 2 bit. So you just divide by 2 equal to 50k. Okay, so frame duration. Frame duration, how long it take to transmit a frame. Okay, so 50k per second. So how long it take to transmit one frame? So 1 divided by 50k. The answer is 20. I think 20 microsecond over here. 1 divided by 50k. This is micro, not milli. Micro. And then bit rate of the link 50k times 8 bit, because each time slot consists of 2 bit. 2 times 4 is 8 bit. So times 50k. How many frame? And that can be transmitted. So the answer is 40 kbps. Framing bit. Okay, this is for synchronization as well. So a bit will be added in each frame for synchronization. So it depends on the synchronization bit. Okay, so the next one is about example 8. We have 4 sources, 250 character. One character equal to 8 bit. Okay, if the interleave unit is a character, okay, a character means 8 bit, and one synchronizing bit is added. Synchronizing bit is added to each frame. So means that each frame will consist of, we have 4 time slot. Each frame, each time slot will consist of one character or equal to 8 bit. So 8 times 4, 32. But don't forget about the synchronizing bit, 1 bit over here. So the total will be 32 plus 1, 33 bits for each frame. Find the data rate of each source. So the answer is 2000 bit per second. 250 times 8. The duration of a character, 1 divided by 250. The link need to send 250 frames per second. This is for frame rate. The duration of each time frame, 1 divided by each frame. So 1 divided by 250. The number of bits in each frame. So 4 bit, 4 time slot times 8 bit. 8 bit over here, plus 1 the synchronizing bit, so 33. The data rate of the link, so the frame rate is 250. Each frame consists of 32 bits, so the answer is 8250 bits.